In 1846, something impossible happened. They discovered a planet not through a cold observatory window, but at an oak writing desk. No bulky copper telescopes, no sleepless nights peering through eyepieces, just stacks of handwritten papers, the scratch of a pen, ink, and pure mathematics. A Frenchman, Urbain Le Verrier, and a Brit, John Couch Adams, completely unaware of each other's work, noticed the same strange gravitational anomaly. Uranus, the seventh planet from the Sun, kept drifting off its rightful orbit. It was as if an invisible cosmic monster pulled it toward the darkness. Step by step, they filled hundreds of pages with complex equations and pinpointed the exact coordinates of this phantom. When astronomers finally trained their lenses on that spot in the empty void, they found it, right where the numbers had predicted. It was a total triumph of human intellect over the very fabric of celestial mechanics. But this victory soon turned into the greatest scientific mystery. Today, we'll explore how this icy giant defies fundamental laws of physics, retrace the timeline of the only historic mission to its orbit, and uncover why its internal heat continues to baffle the world's brightest minds. For nearly a century and a half after that incredible calculation, Neptune remained just a faint blue dot through the lenses of Earth's most powerful telescopes. 4.5 billion kilometers turned it into an unreachable mirage, a cold, ice-bound, utterly lonely world at the edge of the planetary system, where the sun looks like nothing more than an unusually bright star against the black velvet of space. Everything changed in 1989. Voyager 2, piercing the icy darkness of interplanetary space, made the first and only visit in human history to the 8th planet. That faint dot on the grainy control room screens suddenly grew, filling with color, transforming into a detailed, dazzling blue giant. Thick methane haze shimmered in the distant sunlight as the fragile metal probe flew straight over the planet's north pole. For the first time, humanity looked face to face with its most distant neighbor, expecting to find a frozen, lifeless ball of gas and rock. Reality shattered every expectation of classical planetology. Voyager 2 sent back terabytes of data that instantly transformed Neptune from a dull mathematical concept into the most complex puzzle in modern astrophysics. Its sensors recorded storms on a colossal scale and supersonic winds, forces that simply shouldn't exist in such an icy darkness so far from the sun's radiation. The planet emits 2.5 times more heat into space than it receives from our star, blatantly defying the usual laws of thermodynamics. This mysterious internal furnace fuels total chaos in the upper atmosphere, spawning massive dark spots as large as Earth and twisting clouds into deadly whirlpools. Neptune's system wasn't a sleepy outpost after all. It turned out to be a boiling cauldron of mysteries, where even its enigmatic moon Triton acts as if it's alive. All this intense activity demands an enormous energy supply buried deep beneath the blue clouds. What exactly heats the core of this icy giant and turns its atmosphere into the solar system's fiercest storm? The deep blue of this world is deceiving. Through the haze of upper methane clouds, it looks like a frozen sapphire pearl, drifting calmly through eternal darkness. But break through that illusion and dive several hundred kilometers down, and the scene changes completely. Here, a massive climate crime unfolds, one that leaves researchers frozen in disbelief at the first clues. Winds in this dense gas don't just blow, they tear through space at speeds up to 2,100 kilometers per hour. That's nearly twice the speed of sound in Earth's atmosphere. If a modern supersonic fighter jet flew here, the brutal force of the gas would crush its titanium frame instantly, turning the aircraft into a cloud of metal dust in a fraction of a second. This roaring maelstrom spawns colossal storms, none more terrifying than the Great Dark Spot. This giant atmospheric vortex as large as Earth spun counterclockwise, resembling a bottomless black eye on the blue face of the gas giant. Astrophysicists believed this anticyclone was a stable scar, much like the hurricanes on neighboring worlds. But 5 years later, orbital observatories captured something unimaginable. The monstrous spot vanished without a trace, as if wiped away by a colossal rag. Then suddenly a similar killer storm appeared in the northern hemisphere. Such a violent shift demands an extraordinary amount of energy. Investigating this atmospheric chaos pulls us far beyond the visible symptoms, straight into the hidden engine driving the storm. Over 4 billion miles from the central star, an eternal, paralyzing vacuum reigns. Only faint traces of warmth reach here. The daylight feels like dim twilight. According to thermodynamics, the upper gas layers should be locked in a frigid, motionless freeze. But sensor readings shattered that logic completely, revealing the central mystery. This colossal sphere radiates 2.6 times more energy into space than it absorbs from outside. Deep beneath raging methane clouds, crushed under monstrous pressure, an internal heater of unknown origin runs nonstop. This strange underground furnace heats the planet's depths, forcing torrents of molten material to roar to the surface. They slam into the frozen stratosphere, triggering convection with unbelievable power and twisting the atmosphere into supersonic vortices. Scientists have proposed dozens of theories, from friction caused by crystallizing diamond rains deep in the mantle to leftover heat from the formation of our solar system. No one knows the exact answer. But one thing is clear, this gas giant is alive. It simmers and pulses. Yet the most unsettling mystery in this orbiting family doesn't lie in the raging atmosphere. It hides beyond, in the darkness, where the enigmatic moon Triton spins. How does this chunk of frozen rock manage to sustain active nitrogen geysers and conceal a liquid ocean beneath its icy crust, when everything around it has frozen to the breaking point? The outskirts of our star system follow a strict gravitational dance. All the major moons of the gas giants obediently orbit in the same direction as their planets. But one massive object shatters this billion-year harmony. Triton races the wrong way. Its orbit runs directly against Neptune's spin. Imagine a giant ring highway where thousands of cars flow in one direction, and a single heavy truck barrels head-on through them all. In celestial mechanics, anomalies like this never appear out of nowhere. This stands as undeniable evidence of an ancient cosmic kidnapping. Long before the first multicellular life appeared on Earth, Triton wandered freely through space. It was born far beyond the familiar planets in the twilight zone of the Kuiper Belt, a chaotic jumble of primordial ice, dust, and rocky debris. This massive world, nearly as large as Earth's moon, drifted too close to a gas giant and got caught in an invisible gravitational trap. The capture was brutal. Neptune's monstrous tidal forces twisted and stretched Triton's core with such intensity that solid rock groaned and melted. This relentless strain turned Triton's interior into a blazing furnace, melting its original surface and erasing ancient meteor craters for countless millennia. As it cooled, its icy crust cracked into a complex web of deep grooves, like the wrinkled rind of a giant melon. Now trapped, this captured world was doomed to slowly spiral inward, its elongated orbit rounding out over eons through immense internal friction. Today, the surface of this captive world looks like the picture of absolute calm. The temperature plummets to minus 235 degrees Celsius, an extreme cold that changes the very nature of familiar gases. Nitrogen, which fills our lungs with every breath, here falls as solid, transparent snow, building ringing ice cliffs. By all the laws of thermodynamics, Triton should be a lifeless, frozen rock, forgotten on the edge of the universe. But when the images from the interplanetary probe landed on astrophysicists' desks, their initial confusion turned into awe. Dark dust fountains burst through the cracked icy shell at incredible speed, shooting into the black void. These are active cryovolcanoes. Nitrogen geysers pierce the thick crust, erupting up to 5 miles high. Then the thin atmosphere sweeps their plumes into long horizontal streaks, stretching for hundreds of miles. These eruptions take place in complete cosmic silence, scattering organic soot across the pristine white plains. What looked like a dead rock turned out to be a living world, pulsing with energy despite the paralyzing cold. Geological activity on this scale demands a powerful, steady heat source. Studying these emissions led researchers to an astonishing discovery about the moon's interior. Beneath a thick, multi-kilometer shield of frozen gases lies a vast global ocean of liquid water, potentially holding more than all the water on Earth combined. In complete darkness, this ocean stays warm from leftover tidal friction, constantly interacting with a rocky core. This hidden chemical workshop closely resembles Earth's deep-sea hydrothermal vents, the very places where life on our planet began. Suddenly, this distant icy moon has become one of the most promising targets in the search for extraterrestrial microbes. a genuine oasis of life tucked away at the edge of a frozen abyss. But proving the existence of this hidden ocean poses an almost impossible challenge for humanity. The billions of miles between us stretch communication to a frustrating crawl, and without strong sunlight, spacecraft lose their usual power sources. So is the reward worth the risk? Do Neptune's secrets justify such enormous costs? 4.5 billion kilometers of absolute emptiness separate the concrete bunkers of Earth's mission control centers from Triton's elusive icy shell. Launching an expedition to this hidden, ice-covered ocean is like planning a massive interplanetary heist, where the ultimate prize is unlocking the mystery of life's origins. Just reaching this cosmic crime scene will force engineers to hurl a multi-ton probe on a journey lasting around 15 years. This metallic scout will glide silently through deepening darkness, drifting farther and farther from the warmth that sustains us. But the real technological nightmare isn't the agonizingly long trip. It's trying to keep control of this mechanical intruder. Massive 70-meter antennas on Earth will send a command package, and this radio beam will race through the vacuum at the speed of light for a full 4 hours just to reach the spacecraft's receiver. Then, telemetry will take another 4 hours to travel back. An 8-hour communication delay makes manual piloting physically impossible. If the probe's scanners detect a sudden burst of nitrogen gas or a dangerous ice cliff directly in its path, Earth will learn about it too late. The robot has to become a fully autonomous being, capable of analyzing threats, adjusting its orbit, and selecting targets for its spectrometers at the edge of the abyss, while its creators sit helplessly, biting their pencils in front of screens showing hopelessly outdated data. Surviving in this pitch-black darkness to unlock the secrets of the gas giant demands a complete break from traditional space technology. At such a vast distance, the usual wide solar panels become nothing more than dead weight. The radiation from our star is so weak here, it can't even power the simplest onboard clocks, let alone the powerful radars needed to scan through kilometers of ice. The only way to keep the mission alive is to build a personal pocket-sized sun into the spacecraft. At the core of the system lie radioisotope thermoelectric generators. Inside heavy, multi-layered titanium capsules, glowing pellets of plutonium constantly decay, emitting a steady, searing heat against the backdrop of cosmic freezing. Specialized alloys convert this deadly radiation into pure electricity, powering the probe's electronic brains even at temperatures near absolute zero. Only this reliable nuclear reactor can push instruments through Neptune's raging atmosphere, measure its mysterious internal heat, and send precious data packets across billions of kilometers of ringing silence. Building such an autonomous explorer demands billions in funding and decades of meticulous work from entire research institutes, where even the smallest mistake in soldering can turn a monumental triumph into a frozen hunk of space junk. So why is humanity willing to take such an unprecedented risk for a single cold, hostile point on the far edge of our stellar neighborhood? The answer lies far beyond the familiar stars we've studied. For a long time, astrophysicists treated the structure of space around us as a universal standard. It made sense to assume that other parts of the galaxy would also be dominated by giant, scorching balls the size of Jupiter, or smaller, rocky spheres like Earth. But once orbital telescopes began sweeping across the Milky Way in bulk, the cold truth shattered this comfortable belief. It turned out that ice giants are the most common type of exoplanet in the entire observable universe. Hundreds of millions of these worlds scatter across the galaxy's arms, silently orbiting distant stars in pitch-black darkness. Trying to study their faint outlines from hundreds of light years away is nearly hopeless, like trying to understand the workings of a complex clock from its shadow on the wall. Yet the eighth planet lies right in our cosmic backyard. By unraveling the secrets of its roaring methane storms and hidden internal heat, science will gain a universal key. This massive world can translate the physical nature of thousands of distant, unreachable planets for humanity. But this blue giant's value goes far beyond its role as a galactic translator. Its vast distance from the central star transformed it into the ultimate safe deposit box. While the rocky inner neighbors melted, shattered under meteor bombardments, and permanently altered their chemical makeup under relentless radiation winds, the dark outskirts held on to their pristine calm, The eighth world stands frozen in darkness, an enormous, untouched time capsule from the early solar system. Within its dense atmosphere, beneath crushing pressure, and in the turbulent sub-ice oceans, molecules remain locked in their original form. The very grains of ice, gas, and dust that shaped every structure around us more than 4 billion years ago. Reaching these untouched layers means touching the original blueprint of our star cluster's formation. That's why multi-billion-dollar budgets and decades of grueling engineering make every cent worthwhile. The risk of turning an expensive probe into a frozen hunk of metal fades beside the chance to read the universe's oldest, long-erased chapters. The clock of great anticipation has already started ticking. Leading aerospace laboratories are right now designing the architecture for new flagship missions. Engineers plan to launch heavy nuclear-powered probes by the early 1930s, aiming for these spacecraft to reach their target orbit by the 1940s. This will mark a completely new era of exploration. Artificial intelligence will replace fleeting flybys with years of careful, methodical scanning of every crater and every swirling cloud. When the first of these probes settles into a stable orbit, a grand circle will close. A story that began in 1846 with the scratch of a goose quill on paper and elegant mathematical formulas will find its final physical form. The human mind, having calculated an invisible gravitational anomaly through sheer thought, will send its titanium avatars into this icy abyss. Beyond this frontier lies the unknown, where the biggest questions about humanity's place in the infinite void await their answers.